Okay, here's a little update to my first video about Powerbank modules and all that stuff. I'm going to include some other things that I've gotten from Aliexpress lately that are worth buying. Number one being, finally got an active balancer just to try one out, because I do have some A123 12-volt packs, one of which I'm actually using right now for lighting, so it's going to fuck it up, but this is 4S 8P in a 30 cal ammo can with a 100 watt Cobb LED light. I'm using an XYS3580 to buck boost the voltage and really control the current, because that's the issue with LED lights. And the problem is the maximum voltage for that thing is just over 13 volts, I think. So the battery pack does dip under 13 volts. So in order to use the full 20 amp hours, you need a buck and a boost. And that's really the only module there that does 5 amps. There is a version that does 6 amps. That has a screen that's easy to use. So yeah, if you guys know any better way to incorporate a 12 volt lithium iron phosphate battery with a 12 volt Cobb LED that maxes out at like 13 point something, and you know, it was a max of 5 amps, let me know. Because you know, the problem is that thing, it has a little fan on the back, but it doesn't work the greatest. It gets a little hot if you run it over 3 amps and can shut down. And it's expensive. It's like almost 25 bucks. And I'm trying to find something cheaper that I could slap in there that also my parents would be capable of operating. But anyways, these active balancers are super duper simple. The one thing I don't really like is, because it's a 5 amp active balancer, you need a 1 volt voltage difference between the cells for it to actually balance at 5 amps. As the voltage difference goes down, the amperage decreases. So if you slap this onto something that's almost balanced, you're going to see 50 milliamps. And you're going to be like, oh, what the hell? It's because there's no voltage difference. It operates on the voltage difference. This is a 3.86 millimeter pitch. I think it's a JST connector of some type. I can't really find much on these. And the problem is I want to be able to have an adapter between this pitch and the standard 2.54. It would just make things easier. But yeah, it's your typical, you know, this is for a 3S or a 4S. I think you just don't use this one then. I think you just don't use this one, the white one, and then it can be 3S. But really the best part about this is it has a little run pad that comes soldered together, so short-circuited. If you undo that and put a switch on it, it's an on and off switch, which is really important because if you have this permanently attached to a lithium iron phosphate pack, you only want it turned on when you're up at the highest voltage range, like past 3.45 ideally. If you try to balance under 3.3, you're gonna have a lot of issues, because voltage does not mean anything about state of charge in that 3.0 to 3.3 voltage range. One pack could be at 3.24 and could be 40%. The other one could be 3.24 and could be 70%. So when you try to balance based on voltage, then you're not actually balancing, you're just playing the voltage game, which means nothing, and it's just a cluster. So yeah, these are really simple. It's just a bunch of, I believe these are just MOSFETs that do the switching, and it just shuffles the energy around. And I mean, you lose very, very little energy even if you leave one of these on a pack and leave it on for days. And these are very, very accurate. I think they say they're within 2 or 5 millivolts. These are like down to the millivolt accurate. They perfectly balance a pack. It's amazing. So, you know, even if your packs aren't, you know, going way out of balance or anything, this one is $15 on Aliexpress. The bigger ones get more expensive, like the 16S is like 50 bucks-ish. Yeah, that's a little pricey, but if most of your packs are 4S or most of your packs are 12S, get one that works for you and that hopefully you could use on multiples. They even make more expensive ones that are Bluetooth capable. Those look cool too. If you have a big lithium iron phosphate pack with 280 amp hour cells, I think this is a must-have. It just makes your life easier because your average BMS is going to have a balancing current of 60 milliamps, 100 milliamps. If you got a JK, it might have 2 amps. These things are just best things since sliced bread. I cannot say enough great things about them. I have not found a single downside to them, and they're simple. It's like wiring up a BMS. What I've seen people do is they'll take a terminal strip. I call it the kind that the British people use, the white ones, and they'll use solid core wire, and they'll solder the solid core wire to the pins on here, and then on the other side of the terminal block they'll have their BMS balancing wires, and they'll have it all kind of connected through the terminal block, which is pretty smart. So if you're permanently putting it on a big pack, that might be a good idea. Here's the connector on that. I think it's a JST. Apparently it's like 3.86 millimeter pitch. So yeah, best thing since sliced bread. I now see some 7 amp ones pop up, and they're roughly the same price. I'm guessing the capacitors are just larger. There's also some 2 amp ones. Avoid the 1.2 amp ones. I don't think, from everything I've heard, those aren't worth it. I've heard good things about the big inductor-based ones. There's a lot of like 8 and 10 amp ones that are based around inductors. I don't know how those work though. Okay, so what we came here for, really, I don't know if I showed you this last time. I don't think I had it. This is the SW3518S in a 4-channel. Each individual channel can do 100 watts PD 3.0. It's got QC. It's got every major protocol. Downside is it's a buck. So to get 20 volts PD, you need 21. But I've actually found that you can get away with like 20.3, although that may not be the case under a big load. It may be that you need the full 21 volts if you're trying to pull 5 amps. If you try to use both ports, you'll only get 5 volts out of each port, so keep that in mind. But I was thinking about putting this in a project box, but the only thing I have right now is like this little thing, and this doesn't fit. But looking around on YouTube, I could make a video called YouTube's biggest PD charger, and no one's got a 400 watt PD charger on YouTube. I've seen some desktop chargers. February 22nd store has a whole slew of them. They actually have an 800 watt model, which I'm pretty sure is just kind of like 2 of these in a box. The only thing is, to power this, you're gonna need over 20 volts, and you're gonna need a total of 400 watts if you wanna pull 100 from each channel. You could buy a power supply. Be careful if you buy one off Aliexpress, because if you buy a 24 volt 20 amp, you go, oh, that's 480 watts. No, that's Chinese watts. Divide it in half to be safe. It'll probably pull 75% of its rating. But if you're not aware, those Chinese power supplies they're not a mean well. So what I'm actually using to power this and try to test it, I have not tested it up to 400 watts because I just don't have a way to do that. I've pulled 100, and like 30 on one and 60 on another or something, so like 300 watts. To power this, I actually used my 2 HP DPS server power supplies that I have in series. So it makes it like 25 volts, and it's 460 watts each, so that's a total of 920 watts, so plenty of power there. Most people use the 1200 watt versions, which, keep in mind, if you're on a 110 volt, 120 volt circuit, it's going to only be 900 watts, but still it's an absolute enormous amount of power. You put those in series and you run into the issue of you possibly can't run on the same circuit breaker in your house because you're pulling so much wattage if you were to actually use all the power that it has. They're most commonly used with like iCharger, 406s, 408, 4010s, or if you're fancy and you got the new 456 or 458 DX8, even if you just have an iCharger S6 or something, the HP DPS is the kind of go-to. They're cheap. The 460 watts are $10. The 1200 watts are $20, and they're pretty easy to put in series. On one of the two, you need to isolate the DC side, which is really just a matter of pulling out two of the bolts that hold the back of the board in place, and then putting washers underneath that are plastic, and preferably you'd want to use nylon screws or something, just so that you know it's well isolated. But yeah, I've looked around for just a basic like laptop style power adapter for this, so that I could put this in a box and someone could just plug in, but catch is, this is limited to like 10 amps. These, I've never seen one rated higher than 10. So that's 240 watts potentially. The max voltage on here, I believe, is 28. That's why I'm comfortable going with 24, 25. Does it say on here exactly? Oh, voltage in, 6 to 32. So yeah, 24 or 25 is totally safe. The only thing I don't like about this is compared to I have a 3516, I have some single ones. This is actually a little bit longer. And I'm guessing they did that so that, you'd have the pads here, you'd have plenty of space, and so that they'd have room for this, which kind of makes sense. But yeah, I've had no problems with this overheating. I haven't run it terribly long, but it seems to be a solid unit. So if you want to build a 400 watt PD charger, this is it. You could just find a 24 volt, 10 amp like power adapter and plug in, and that way you'd be mostly powered, because I doubt you'd actually use all 400 watts unless you had 4 MacBook Pros charging off of it or something. But yeah, this would be a super duper cheap way to make a PD desktop charger that, you could run anything on pretty much, because this is $20. A 24 volt 10 amp power adapter, I've seen them in the $30-$40 range, or you can go the HP DPS route like I did. $10 for each power supply, $10 for the nylon bolts and washers, and what else? I got some heat shrink so I could isolate each one, and I also put a layer of acrylic in between the two, and then I stacked them on top and then heat shrunk them together. But yeah, really so it's a total of like $50, 20 for this, 30 for making your power supply. You could have a super powerful desktop charger. Sorry for the camera moving around. I don't know if I had this last time. This is a TZT board. I think TZT is the originator of it. They're a shop on Aliexpress. I actually really like this thing. It's based off the IP5389. I'm still not sure if the 5389 is a true 100 watt capable chip, or if it's just a matter of the specific board that it's on and the MOSFETs and all the other components. I never was able to pull 100 watts from this. However, they did recommend that I use 16 gauge wire at a minimum, and I think that may have been an issue. I think if I had stepped it up to 14 here, the resistance may have been lower. These boards are always very picky about resistance, so that's why you want the shortest length of wire and use the thickest wire that you really can get away with. But this thing died on me. I had it for like 2 weeks, and it just took a shit and stopped working. I actually really like this though, because you got your bidirectional C port. The micro port, freaking pointless. This is a lightning port, so if you had a lightning charger for your iPhone, you could then plug the lightning port in here and charge it at 20 watts or whatever. I didn't get a chance to use the DC port. I can't remember if that was input and output. Yeah, I don't remember, but I really like the power banks that have a DC port too as an option. But yeah, this comes in a 3S version that's 65 watts, 4S, and 5S, I think. Some places will sell it to you set up the way you want it. You'll select if you want 3S, 4S, 5S. Other places, they just sell it to you and you got to swap the resistor if you're not doing 4S. Yeah, I thought this was a great board. Sucks that it took a shit, but I got my money back. The fuel gauge seemed to be accurate. I didn't like how, let's see, where are you, camera? Here's where you put the balance wires. Those are so damn close together. I did not like that. It was easy to, get those too close, and I was so paranoid doing that. The IP5389 is it under the inductor? Oh no, it's under here. So yeah, it's tucked under there. But I'm probably gonna get another one of these because I really liked it. It's it's about the right size. The problem is finding project boxes is such a pain in the ass because even if the website does allow you to search by dimensions, it'll be the outside dimensions, and those are fucking useless for me. I need the inner dimensions. So if you know a great place to get project boxes, specifically ones that maybe are meant for 18650s, 21700s, but don't use the cell holders or have the stupid little springs, I don't do any of that. Let me know, put a comment down. Where do you buy project boxes? Does anyone have a website that lets you search by dimensions, and especially inside dimensions? That would be helpful. Yeah, I still got this, and my plan actually was maybe to put these two together, because you can't really use these if you're using the C port. But this would kind of give you the option of, well, do you need a port with QC 3.0? Are you using the C port? No big deal. Got this. Dude, these are less than $6. I've seen them for $4 now. You'd be crazy not to buy some of these. You just might as well. Because these are Buck units, but, if you give this 6 volts, it gives you 5. So you got 5 volts, 3 amps on each one. Power goes out, you can slap any little batteries together that you can manage, and you can charge phones. I finally bought one of these. My future sister-in-law saw a power bank that I made that I'm going to show you guys in a minute. She wants one, but it has to be pink. So I bought a pink shell, but I got to find a board that fits in there, and this one almost fit in, but this was also broken too. I might have broken it. Shh, be quiet. Don't tell anyone. You can't do more than 4.2 volts to this, even though the chip on here is capable to like 26 volts or something. It's weird. This is the IP5328. Let me check. Yeah, 5328. This is the P version. I don't know if that makes a difference. These are great because it's just one cell in series, and it's up to 18 watts, so 9 volts 2 amps, 5 volts 3 amps, and I think these are quick charge 3.0. Oops, sorry. So yeah, these are great little boards. They're like $3. Definitely highly recommend. let's do the one that I built. So I bought one of these because I saw them all over Aliexpress and I was curious. This is the model that does like 20 or 22 watts output, and it's a 4-cell of 21700s. The only strange thing is it's 1 cell in series. So the way they have you build it, let me grab some. They have you build it like this, and then with another set right above it. So what you gotta do is you take 2 cells like this, you have a piece of nickel going up, and then it's gotta come up a little bit because you're gonna have to solder onto here, and you're gonna have to bend it over, and then spot weld 2 more here, and it's just really awkward. It's really awkward to build. And then you're also gonna have here and here, you're gonna spot weld, and there's a spot on the board here and here for the positives, and 1 spot here for the negative. And that's your little bump that comes up in the middle. And that's kind of a pain to solder to and everything. But yeah, I used some Lishan cells that I had randomly bought a while ago, and they're 4,000 milliamps each, milliamp hours, and I think they're rated for 12 amps, so they're perfectly fine cells. I'd like to get some Tesla cells so I could build some power banks with the most capacity possible. These I actually got off a power bank, and they seem to test to like 4800. This one does just a bit more usually. Ignore the 4500s, that was on a tester that doesn't go low enough. And this one, 4981 I got out of it one time. 4724 recently. Yeah, they're like 4800 milliamp hour cells. I think that may be an old version of the Tesla cells. But yeah, on this power bank, you got 2 A slots. You got a bidirectional C, and then you have the lightning, same as that other power bank module. You got the lightning input, so if all you have is an Apple charger, you have a way to charge this technically. The fuel gauge seems accurate. It shows you voltage, amperage, and whether it's in or out. And this is fairly accurate, it's close. I think it's a little low, but let me show you. So the display on this uses about 100 milliamp, so that's actually correct. 5 volts, yeah, that's correct. So now we're showing 1.3, that's a little off. 5.1, that's a little off, maybe, could be a loss. Okay, we're actually way off here. This says 2 amps, this says 2.6, but I feel like the C port was more accurate. But as you can see, the voltage hasn't dropped here, and we're at 2 amps, so that's a good sign. It's still doing really good over 2 amps. Still boosting itself up, so it's regulating itself. Now it's starting out, it's regulating till, it's gonna regulate a little past 2.5, I think, and then drop off. Still regulating itself. Still regulating itself. Still regulating itself. 3 amps. This says 3.9 now. Okay, that's way off. I think now we're gonna tail off. Yeah. Although it's still trying to regulate. We're at 3.2. .3. .35. Now it's struggling a little bit. It's gonna drop. 3.7. Yeah, and okay, yeah, there you go. So pretty impressive off the A port. You can definitely go over 3 amps there. Just out of curiosity, let me see if the C port is a pain too. Which one is it? Bad about doing this on your street. Maybe I have to hit this. Yeah. Strange. Okay, let's try this another way. Might as well go through protocol detection. This is the C port. So that's PD, 22 watts, 4 PDOs. And QC3 up to 12 volts, Huawei, all that good stuff. Oh, it turned off. Let's go back. These FNB 48s are down to like 25 bucks, so if you're not doing PD 3.1, these are a great deal right now. 5 volts 2.4, 9 volts 2.22, 12 volts 1.67, and it's got PPS. That's pretty nice. And it turned off. Stop turning off, you bastard. So if I were to hook up through here, now it turns on. So 1 amp. And we're showing 1.2. Let's go until the FNB says 2 amps. Because I trust the FNB to be more accurate. Right at about 2 amps. This is 2.4, so I guess it's this thing that's not accurate. But yeah, great little deal. It was, when was it? $10 or I can't remember. It wasn't that expensive. I would recommend. It's a little bit of a pain in the ass to build, but I've used it quite a bit, like a lot. I've kind of retired my other power banks. It's kind of my being lazy around the house, don't want to be plugged into an outlet and kind of stuck with it. So each cell is 4,000 milliamp hours, so it's like 16,000 milliamp hours, and I get a solid 4 charges out of my phone, which is about right after the efficiency losses. I bought a bunch of silicone cables, USB-C to USB-C. This one is apparently a 240 watt, 20 gigabits per second. I need to find a way to test the 20 gigabits a second thing. I have no way of testing 240 watts because I don't have anything PD 3.1, so I don't even have a way to test 140 watts, but if, I'd have to power this somehow. Anyways, I tested the cable, and it is capable of at least 100 watts, so that was good enough for me. I bought from 3 different sellers, and this is the really dull orange ones that I got. And these were probably the worst that I got. The silicone on here is like all dried out, and these are really dull. But I think these might have the, yeah, there's a light in the back here too, and there's a light on top there, just on one side. I think this is from a different seller. It's not as dried out. It does have the same light and lights up back here. This seller overall gave me the best cheap cables. The 240 watt ones were a little more expensive. These were like $4 a piece. What else? I'm almost up to the last of the Powerbank modules. Bought an RC3563. This is a milliohm meter. I can't believe I lived so long without this. You need to get one of these if you mess around with batteries at all. And even just sometimes, you know, wanting to see on some copper bus bars or something, how much resistance is there? Are these actually good bus bars? This is all you need to know. This will tell you everything. So 14 milliohms. I need to charge this 3.15. I just tested it. Let me grab Molly cell. Here's a P42A. 9 millivolts. And here's an A123 M1B. 5.7 millivolts. So yeah, these probes that it comes with, it's one of the options. You can also get the, they kind of look like alligator clamps. They're called Kelvin clips. I'm probably gonna order some Kelvin clips because they look pretty useful in situations where this is not ideal. There's an advanced version or enhanced version of these probes. I don't like the looks that they have for the RC3563, but on the YR1035 Plus, they look a lot better, but it's a different connector. This I think is a GX16 and it's a 4-pin. So it'd be really easy to make my own. Charged with micro. It's got a little lithium battery in there. No special features, nothing, just straight up voltage measurement and Measures pretty far out in milliohms. Oops. So you get 3 digits past the decimal. I think on the YR1035 Plus, you only get 2. Not a huge deal, but maybe if you're doing some gigantic lithium iron phosphate cells, you may want all 3 digits. I have a giant collection of vapes. Here's just the ones that I haven't taken apart. I have over 100 that I have taken apart and pulled batteries out of. The Elf bars only have like 650 milliamp hour batteries, whereas these came off some vapes that I used to use like a year or so ago. Max Flow Duos or something, I can't even remember. These are 1350 each. So I did 2 in parallel, and then it's 7S, 24 volts. That brings me to this little guy. This is a PD 3.0, 65 watt max, so 20 volts, 3.25 amps, PPS too. And I've tested this quite a bit. It works on a MacBook. It really does put out 65 watts. It doesn't overheat. It's incredible. I thought this was going to overheat like a mofo. You just have to search 65 watt PD PPS module and you'll find this. You'll also find longer variants that have a DC jack. There's also another one with an XT30, but it's a little expensive. It's like $5. These are like $250 each. Buy these because these are probably going to go up in price as these get popular. But yeah, they're buck units, so you got to put in more voltage than what you're going to use. But dude, these are a stinking good deal. And yes, I used this battery to charge a Mac for like 20 minutes and it worked just fine. But this is kind of shady. I don't trust this thing. There's no data sheets out there for this. The way I've put this together is kind of but I also bought a bunch of barley paper because I found it really cheap. I bought a bunch of heat shrink because I found it really cheap. If you want me to tell you what stores to go to get it, just leave a comment. I'm not going to waste my time posting links to everything. If you can't find this stuff on your own, you shouldn't be fucking around with lithium anyways. And then these are just my favorite PD triggers. They're cheap. I can find them for like $2 each. I actually had to reattach a button on here, and that's why it's all fucked up looking. But yeah, this plugs in. You push. Well, actually, these come locked. There's a set of like you plug it in holding this one, and then release this one, and then do this to unlock it or to set the voltage. But once it's unlocked, you can plug it in and just push up or down to change the voltage, and the light moves for whatever voltage you're trying to get. And then you have 2 output options, and it's just simple to the point. Here's, kind of explains to you here how to work it. Damn it, it's this light. Oh, that's better-ish. Where's the camera lens on this? I can't see shit with it on this. Oh, yeah, that's way better. So if you hold S minus as you plug it in, you get 9 volts. If you hold S plus, you get 12. If you hold both, you get 20. If you hold S plus, and then once you plug it in, you hold S minus, and then release S plus, I think that's how that works. I don't know. So the mistake that I made was I didn't really read, and this is the 5 volt 3.1 amp. This is the 5 volt 4 amp. should have read before I bought 3 of these. I have some more. Those are the 4 amps. These are the 3.1 amps. I bought 3 of each. This one doesn't do anything besides 5 volts, which isn't terrible, you know. It's a little module. And I think this one, yeah, this comes with this soldered in. This one doesn't. I just popped it on there. I haven't soldered it yet. Easy enough to do. So I wouldn't recommend getting these because all you get is 5 volts. This, however, this gives you 5 volts, 9 volts, 12 volts, up to 18 watts in this little package. I've only tested it with my power supply connected, so I really need to hook this up to a battery. But just my 20 minutes of testing shows that it works. It doesn't get too hot, and it's freaking tiny. I don't have my calipers in here, do I? No. But, I mean, yeah, this thing is... I mean, this is 18 watts, but you get multiple ports. This, you get, I think, everything you need, and it's half the size. So, I mean, this would work on the smallest single-cell power banks, 2 cells. Just be careful, because if you're trying to get 12 volts, 1.5 amps out, that's 18 watts. If you only have 1 cell at 4 volts, that's running it at like 4.5 amps. So don't be using some garbage cells, because that ain't gonna work out well. And then I've had these holders for a while. These are my favorite. These are directly based off the Keystone design, and they seem to be pretty quality. Here's what they say on the back. Blossom Electronics. These are for 18650s. I needed some for 21700, so I decided to try this. And these are the Bella Moo. I have some other Bella Moo ones, and their stuff is a little cheap, I think, but these were cheap, so I'm not gonna complain. This design actually, though, sucks in a way. I don't think it puts enough pressure, and these contacts are steel, so when I put a 15 milliohm cell in here and then use my milliohm meter, it was at 30, so these put 15 milliohms added to it. Not ideal, because I want to say this added like only 6. So these are dirt cheap. They work, especially for some reason with, I don't even know which way this is supposed to go. Should it go like this? No, I think this contact is probably for the positive, so I think this makes more sense. It holds these cells. It does not hold my moly cell in very tight. And that's because you only have 1 spring. So yeah, I like these though, because on some of my other holders, you need a tool to get the cells out, and it's kind of annoying. It makes great contact, has, you know, maybe a little less resistance, although with these cells, it seems like the resistance is as good as it's gonna get. This seems to be enough pressure, but with this, I'm sure it would suffer a little bit. So yeah, there you go. That's kind of all the new shit. I just sold a bunch of parts, some other stuff, so I'm probably going to be buying some new things, but if there's something out there that you think I might like, leave a comment, let me know what it is, and if it's under $100, I might consider it, but I'm waiting to get my capacitors in from Korea. I ordered some 3000 farad capacitors to build a spot welder. I still need to buy the control board for that, and the FETs and the FET board. But I bought some 6-gauge wire, some really nice silicone stuff. So, yeah. See you later, dudes.